Have you ever wondered why adding an extra field to a struct can significantly improve its performance? It sounds strange, but it's true. Today, we're diving into the fascinating world of programming performance and exploring this very question. I totally get it. You might be thinking, how can a simple struct wrapping a single float be slower than using a float directly? You're not alone in this confusion. Many developers have faced similar performance issues. Here's the specific situation we're looking at. One user noticed that a struct wrapping a single float was significantly slower than using a float directly, with performance dropping to about half. Sound familiar? Let's explore why this happens. So, what could be causing this performance drop? It turns out that the way structs are handled in memory can lead to unexpected results. We'll break down the mechanics behind this to help you understand. And stick around. By the end of this video, you'll not only understand the issue, but also learn how to optimize your code for better performance. To understand why adding an extra field to the struct improves performance, let's first look at how memory alignment works. The user should know that structs in C# are stored in memory in a way that optimizes access speed. When the user wraps a single float in a struct, it may not align well with the CPU's memory access patterns. This misalignment can lead to slower performance due to additional memory accesses. By adding an extra field, like a Boolean, the user effectively increases the size of the struct. This change can lead to better alignment with the CPU's memory architecture, resulting in improved performance. The user can also consider the effects of the just-in-time compiler optimizations. The JIT compiler may optimize the memory layout of larger structs more effectively than smaller ones. In summary, the user has discovered that adding an extra field to a struct can enhance performance due to better memory alignment and JIT optimizations. This is a valuable insight for optimizing code in C#. Fun fact, did you know that the way data is aligned in memory can have a huge impact on performance? It's like how a well-organized closet makes it easier to find your clothes. Now let's look at the answers provided by other users. The benchmark results show that the float performs best, followed closely by the enhanced struct. The basic struct, however, lags behind. This illustrates the importance of memory layout in performance. In conclusion, adding an extra field to a struct can lead to better memory alignment and improved performance. Remember, understanding how your code interacts with memory is key to optimizing performance. And there you have it. Now you know why adding an extra field can make such a difference. If you found this video helpful, don't forget to subscribe for more programming tips and tricks. This user points out that the performance issue may be due to misalignment in memory. They suggest that adding an extra field to the struct can help optimize it, especially in 64-bit mode. They also mention that calling console.writeLine can affect timing, making it similar to the performance of the modified struct. The user also references a previous discussion about struct size recommendations, suggesting that structs smaller than 64 bits may not be optimized in 64-bit mode. Let's take a look at an answer from another user. This user explains that the performance difference between the two structs is due to how the just-in-time compiler optimizes assembly code. They note that while the common intermediate language code is similar, the assembly code generated for the vector1 and vector1 magic structs differs significantly. They highlight that the JIT compiler treats structs with multiple fields differently, which leads to better optimization for vector magic. The compiler seems to expect operations on all fields, even unused ones, which improves performance.